yesterday, or Tuesday, we were looking at, let me bring it back up. We looked at the total percent of music sales since 1998, and we noticed that when we graph them, they look like a line, but it's not quite a line. So we used what we call linear regression on the graphing calculator to find the equation for the line of best fit, which is the line that fits most of the points, or is closest to most of the points. And we also noticed that it was a decreasing linear looking function, and we decided that was because why? Why were music sales dropping? Because of the internet, the computer, iTunes, so it makes sense, right? Because how many CDs do you guys actually own now? A lot, but they're all old, right? I don't think I bought a CD since junior high, high school. So, but a lot of times you can buy everything you need straight off the computer, so it makes sense that it's declining, right? So we came up using the graphing calculator with the linear regression equation, y equals negative 2.97x plus 48.98, and we got that using the graphing calculator, and it gives us the line of best fit for this set of data. So we should have all of that in there. And then we defined interpolation, which is to use linear regression to make predictions within the data set. And we did one problem regarding that. So I asked you to use the equation to predict the total amount of sales that came from the year 2000, which, because remember we started in 1998, that means we plug in x equals 2. When we did, we got 42.97%. And our actual percent was what? 43, so it was close, right? So that's what I want you to write down for the next part. So the next part of that was to compare the predicted percent to the actual percent. So when we compare the predicted percent, which we got to 42.95, to the actual, which was actually calculated, we saw that the actual percent, so let's write that down, the actual percent you guys want to look in your notes, what was the actual percent? What did it come out to? $42.4. Okay, so the actual percent is 42.4%. So was the predicted value close to the actual value? Yes. Yeah. So let's write that. So the predicted value was close to the actual value. And the reason that we do, and inter means inside, right? The reason that we do interpolation is to check our equations so that when we check it against an actual value that we have, we know if we're close. Because then we're going to start making predictions about data outside of the data set that was given to us. So what I want you guys to do right now is use the equation that we wrote down in the previous part to predict the percent of total music sales that came from music source in the year 2003. Now remember, we don't plug in 2003, we plug in how many years since the first year. So if 1998 was where we started, what would 2003 be? 5? Okay, so let's plug in 5. So x equals 5. And I'm going to have you guys do the exact same thing that we just did as a class. So I want you to use the equation to predict, and then I want you to compare the predicted percent to the actual percent, okay? Okay, so we already determined that for the year 2013, x has to equal 5. So what did you do first, Brittany?
I plugged in 5 for x. You
plugged in 5 for x. So what did the equation look like?
Y equals negative 2.97 times 5 plus 48.89.
Perfect. Okay. Dolly, what did you guys get for negative 2.97 times 5? Negative 14.84. 85. You guys agree or disagree? Agree. Okay, plus 48.89, and then Dana, what did you get as y equals? 34.04. So, Andrew, what was the actual percent of music sales in 2013? You didn't know? Didn't you write it down? Okay, somebody else in your group, what was the actual percent? 33.27. Is that what it was, guys? 2003, 33.2. Okay, so the actual percent is 33.2. So was the predicted value close to the actual value, everybody? Yes. So the predicted value so does it seem like our equation is pretty accurate? Yeah. Okay, to the actual value. Good. So we performed some interpolation for 2 years in our data set because remember, inter means within. So if I told you that we also had something called extrapolation, what do you think that would mean? Outside the data set. So extrapolation is to make predictions for values of x that are outside of the data set. So now we're going to be making predictions about future sales or sales in the past that are not within our data set that we don't have measured. Okay guys, so we are now going to use the same linear regression equation that we came up with from the graphing calculators to make predictions for the total music sales that came from stores in these 3 years, okay? So I'm going to do the first one with you, and then I'm going to have you guys do the second and third ones on your own. So let's look at 2010, and we're going to do that one together. If we are plugging in for 2010, how many years after 1998 would 2010 be? What does this come to? 12. Okay, so x equals 12, right? Because remember, we're measuring in terms of years that have passed since we started calculating. So to do this, y equals negative 2.97 times 12 plus 48.89. Okay, who has the calculator handy for me? Okay, what's negative 2.97 times 12? What'd you get, Tom? Negative 35.6. Tom says 4, Brittany says 5.
No, just say 4.
4, okay. Plus 48.89. And Tom, what does that give us as y equals? No pressure. 13.25, perfect. Did anybody else do it and agree? Jonathan, you agree? Yeah, Anthony, you agree? Okay. All right, so I also want us to be able to write our answer in terms of what it means in a sentence. So what does this mean? This means that we predict, where can I write it? Over here. So we predict that the amount of what are we measuring? Music sales in 2010 will be 13.25%. Okay, so that's what we're predicting here. Okay, so what I want you guys to do now in your groups is predict what the music sales will be in 2020, and predict what the music sales were in 1900. So I'm going to start it off with you. If we're looking at 2020, what is X going to equal? 22? Yeah. Okay, because it's 10 years after 2010, so X is going to be 22, so I'll start you guys with that. Now, what about 1900? We're going backwards from when we started calculating the time. So is our X going to be positive or negative? Negative. It'll be negative, and how many years after 1998 is 1900? 98. So it's going to be negative 98, right? So in your groups, guys, and I'll come around to help you if you get stuck, predict for me the music sales in 2020 and in 1900. Okay, everybody listen to Teacher Caleb. So Caleb, come and show us your work for 2020 and what you got. And make sure you explain to us what you're plugging in and how you got your numbers.
So, let's plug 22 into the equation.
Okay.
Right, and then I multiply it. And then I add it.
That's what you guys got? Do you agree? Yeah. Okay, so what is your prediction then? That in 2020, what will the music sales be?
Negative 16.45.
Can you write it in a sentence for me? Okay, so everybody make sure you write it in a sentence. Do it while Caleb's doing it. Let me go off the video really quick. So we predict in 2020 that the sales will be negative 16.45%. Yes? Okay. Okay, so Teacher Brittany is going to show us what her prediction for 1900 was. So we're going back in time. So we had a negative X. Go ahead. Oh wait, Caleb's on too. Go Teacher Brittany. Come on, Teacher Brittany. We'll get to the
I say terrible teacher. Okay. So I plugged in negative 98. And it came out to be 291.06. And then I added it to 48.89. I found a sentence, right?
Yep, right in the sentence. Did you guys get 339.95? Okay. That's a big percent, right? Everybody was buying music back then. More than everybody.
Millions every day.
We're going to talk about in a second if our predictions are reasonable. Okay, you should have it written in a sentence. While Brittany is writing that, what I want you guys to discuss in your groups for a minute are the predictions that we've made for 2010, 2020, and 1900 reasonable? And if so, which ones are reasonable and which ones are not? Okay, so 1 minute discussion in your group, go. Jet. So guys, in our are our predictions for 2010 reasonable? Yes. Why? Okay, it's not too big, it's not a negative. Is it still decreasing from the other music sales? And do you think that it's reasonable that in 2010, so 4 years ago now, that music sales were down to about 13% in stores? Yeah. Okay, what about 2020? Is that a reasonable prediction? Negative 16%. Why? Yeah, less than nobody. You can't have negative. I mean, we could get down to 0, but that would mean all music stores are closed. Do you guys think in 6 years that all music stores will be closed and no CDs will be sold ever? Yeah, music stores sell more than CDs. But do you think that in 2020, if you go to Best Buy, that there's going to be no CDs anymore at all? There'll be some, right? And people will still buy a little bit. So it's not really reasonable that we have a negative percent, right? What about in 1900? Is 300 and almost 340%? Is it possible to have more than 100% of people buying music? No. And do you think they were buying CDs in 1900? No. So we have to look at our linear regression equation that we come up with, and when we do make predictions outside of the data set, we have to ask ourselves, does this answer make sense? Is it actually possible? So if you do get predictions, for example, like negative 16% or 340%, you need to make sure that you can ask yourself, is that a reasonable answer? So in 2010, yeah, 13% is reasonable. I didn't even write it as a percent. But in 2020, I highly doubt that negative 16% of music is going to be sold. Does that make sense? Yeah. Okay. So let's look at another set of data and make some predictions based on that. Okay, so you are going to be graphing them. So draw a coordinate plane for me. You don't have to write out all the words, but I do want you to write the points. So I'm giving you a set of data that is composed of these points. 1, 3, negative 3, negative 7, and 5, 7. Okay, so what I want you guys to do right now is plot those 3 points on the coordinate plane. Okay. Okay, guys, so let's plot those 3 points. Double check what you plotted. So our first one is 1, 3. So which direction am I going to go first? Right 1 and then up 3. So your first point should have been right there. What about the next one? Negative 3, negative 7. Left 3 and down 7. So that's going to be right here. And the last one, 5, 7. Right 5, so that's right here, and then up 7, that's going to be right here. Okay? All right, so everybody should at least get these points. So what I want to ask you, write down this question. Are the points collinear? Write down the question. We'll talk about what collinear means. Okay, guys, let's talk about that word collinear first, and then we can answer the question. What does the prefix co mean? With, together, okay, and then linear, we should know what that means, on a line. So are these 3 points, would you consider them co-linear? Okay, some say yes, some say no. Talk about it in your groups really quick. 30 seconds. Okay, so Dana asked a really good question. She said, because co means together and linear means on a line, does that mean they have to all be like on an exact same line? What do you guys think?
Almost on the line? No.
Does almost on a line count as collinear?
Yeah.
Well, let's think about it. Have you guys ever heard of the word cohabitate?
No.
Like your family cohabitates, it means they habitate or live together. So that's what it means. Okay, so if you, let's say you have brothers and sisters, and you guys all cohabitate, meaning you live in the same house. If you have an older brother that is in college and lives away from the house, are you and your older brother cohabitating? No. No. So if I have 3 points that are almost on a line, but not quite, do you think they are collinear? No. So these 3 points are not collinear because they do not lie all on the same line. Okay, so I want you to write that down in your own words. Okay, so here's what I wrote. Yours should be something like that. No, they're not collinear because all 3 points do not lie on the same line. So let's look at each individual line that passes through any of the 2 given points. So let's look at the line that passes through 1, 3, and 5, 7. Okay, so what we're going to do is we're going to determine the equation of the line that passes through 2 individual points, and we're going to see if any of those can be a line of best fit for us. So let's do 1, 3, which is this guy, and 5, 7, which is this guy. Okay, so what I want you guys to do is let's draw the line between those 2 points first. So first we're going to look at the equation of the line that passes through 1, 3, and 5, 7. And let's figure out what the equation would be. What's our favorite form of a line, guys? Well, all lines are linear. Y equals mx plus b.
Oh.
We're going back to y equals mx plus b. That's like our best friend. Okay? Who remembers how to solve for m? M is your slope, and it's rise over run. So is rise y values or x values? Y values. So remember, we subtract the y values. So do you guys want to do 3 minus 7 or 7 minus 3? Okay, so 7 minus 3. And run is the x's, so remember, we have to do our subtraction in the same order. So because we use 7 first, we have to do 5 first. 5 minus 1. Okay, guys, 7 minus 3, what does that give you? 4 over 4. So what does that reduce to? 1. So our slope is 1, right? Okay. Do we know what b is yet?
Wait, yeah.
I mean, we can look at our graph and kind of estimate. It looks like it's going through 2, but have our graphs been super accurate in the past? Their graphs aren't always accurate because your scale might be a little off or your line might not be perfectly straight. So we're going to have to try and solve for b. And we did do this, but it was a while ago, so let's refresh. So I know what m is. I'm trying to figure out what b is. Do I have a y and an x that I could plug in?
Yeah.
Yeah, which one do you guys want to use? 1, 3 or 5, 7? Let's use 1, 3. Okay, so let's plug it in and see if we can solve for b. So what is the y in 1, 3? 3. So we have 3 equals m, which is 1, times, what's the x? 1, plus b. So that's going to be 3 equals, ladies and gentlemen, what is 1 times 1? 1 plus b. And how would I get b by itself? Subtract the 1 from both sides. Good. Okay, so we get b equals 2. Okay, so remember, if I want my equation to be y equals mx plus b, I now have my m, which is 1, and I have my b, which is 2. So we're going to plug those back into y equals mx plus b, but I keep my variables as y and x, right? Because we need it to be in equation form. So the equation of our line is y equals, my m is 1. Do I have to write it if it's a 1? No. So it's just going to be x plus b, which is 2. This was like all the way back from first semester. Okay, so box it. And then I want you to label the line y equals x plus 2. So that line that we drew, label it for me y equals x plus 2. Okay. I'm going to have you guys do the same thing for the other 2 points. So the first two, -3, -7, and 5, 7. So let's draw the line first. -3, -7 is this one, and 5, 7 is the top one. So now we're going to do the exact same thing for those 2 points. My line is not super straight. Okay. So draw the line between those 2 points. Do the exact same thing and find the equation for those. And I'll leave the work up. Okay? Okay? So, what did you guys get for your M? I was walking around. 1.75. Okay, that's what I got. So, what I did, it's on 3s, that's why. So what I did was I did -7 minus 7 over -3 minus 5. If you went the other way, that's okay too. You would still get the same slope. So I got -14 over 8 equals 7 over 4, which comes out to 1.75. Yes? Okay, so we should be okay. Most of you, when I was walking around, got that. And so we know what the M is. So I'm looking up here at y equals mx plus b. We know what the M is, but we need to find b. What x and y did you guys use? 5 and 7, that's what I used too. So I got 7 equals 1.75 times 5 plus b. So what do you all get for b? B equals -1.75. Good. So 1.75 times 5 gives us 8.75. Subtract that, and we get b equals -1.75. So when we plug that into y equals mx plus b, we have to plug in m and we have to plug in b. So my equation is y equals 1.75, which is the m, and the b is -1.75, so I put -1.75. Okay? So the y equals, the x is multiplied by your m, so that should be your equation. So make sure that you label that on your graph. So up here on my graph, I labeled it. And make sure that your work matches. And I'm going to have you guys do it for the last 2 points. So the last 2 points are -3, -7, and 1, 3. Okay? So -3, -7 is that lowest one, and 1, 3 is the middle one. So do the exact same thing for those last 2 points. Okay? And I'm going to leave all of the work up for you. Brittany, question? Okay, so for this one, I did the opposite than I did last time. So I did 3 minus -7 and 1 minus -3 for my M, which gave me 10 over 4, which gave me positive 2.5. Thumbs up if you got positive 2.5 as your slope. Cool. Okay, so what point did you guys plug in for X and Y? 1 and 3, yeah. So that would be 3 equals 2.5 plus B. Subtract 2.5, so B equals what? 0.5, right? So when I plug it all back in, the equation of my line should be y equals 2.5x plus 0.5. Thumbs up if you got that, or you were on your way to getting there. Okay, so label that line on your graph. So make sure that you label the equation. And then I have a question for you to discuss with your groups for about 30 seconds. Would you consider any of these lines a line of best fit? Okay. What do you guys think? Either my pink, blue, or purple line would be considered the line of best fit for all 3 points? Why? Yeah, none of them go through all 3 points. And if we look at, like, let's look at the pink line. My pink line goes through these 2 points, but is it at all close to the 3rd point? What about the purple one? It goes through these 2 points, but is it close to that one? It's closer, but is it really close? No. And then if I did the blue line, it's not even close to the bottom point, right? So my line of best fit then, would my line of best fit actually go through any of the points necessarily? Okay, so I would say no, none of these are a line of best fit. Let's just say that for right now, because, and then we know it's because it's not really close to all 3 points, okay? Okay, so, first of all, how do we find the line of best fit if we have points that are totally not even close to each other? We use what is called the least squares regression line, okay? And it is the line of best fit that minimizes the squares of the distance of the points. So we look at the line that has the smallest distance between all of the points, okay? Now we know that the least squares regression is y equals ax plus b. We did that on Tuesday, but the calculator did it for us. Now we're going to do it by hand, okay? So here is the equation to finding a. This big E is the Greek letter sigma. It means sum. Okay, so that's what the big E is. And so it's n times the sum of x times y minus the sum of the x's times the sum of the y's all over n times the sum of x squared minus the sum of x's squared. And very similar for the b, okay? So what we're going to be doing is we're going to use these equations to calculate a and b, and then we're going to plug a and b in, okay? Okay, so on your handout, we're going to actually do this. Now, I know the formula looks really crazy and scary, but it's actually not as bad as it looks. And the handout gives you 3 sets of data, -3, -3, 1, 2, and 3, 4, and it breaks down each of those formulas for you, okay? So, let's look at it. The first step, we're going to calculate the values of each part separately and then put it all together. So, the first step is to figure out what n is. N is the number of coordinate points in the data set. How many coordinate points are there? So, n equals 3. N means how much data do we have? Always. That was easy, right?
What?
So n is the number of coordinate points in the data set. So we have 3 points, so n equals 3. So write that in there. Okay? So then let's break it down and let's look at this part, the big EX, so sigma x. Okay? That means, sigma means the sum, and then x means all the x's. So let's determine the sum of all the x values. So what are our x values? -3, 1, and 3. So let's just add them all up. Okay, so what do you get? 1. Okay, so the sigma x is equal to 1. Also not bad, right? So what do you think sigma y means? Add up all the y's. So you're going to do the sum of all the y values. So our y values are -3, 2, and 4, which comes out to 3. Okay. Okay. So then if I have sigma x squared, that means the sum of all the squares of the x's. So we're going to take all the x's and square them. So that is -3 squared plus 1 squared plus 3 squared. So it's basically exactly what we did in the second part, but now we're squaring each of them. Okay? So what's -3 squared, guys? 9. What's 1 squared? 1. And what's 3 squared? 9. So when you add all those up together, what do you get? 19. Okay. All right. So then we have sigma xy. So that means the sum of the products. So we're going to multiply each x and y together in its coordinate pair and add those. So our first coordinate pair is -3, -3. So that's -3 times -3 plus, what's the next coordinate pair? 1, 2. So plus 1 times 2. And then the last coordinate pair is 3 times 4. Okay, what's -3 times -3? +9. Plus, what's 1 times 2? Okay, plus, what's 3 times 4? 12. Okay, so 9 plus 2 gives me 11, and 11 plus 12 is 23. And then the last part is we're going to find the sum of all the x's, and then we're going to square it. So the sum of all the x's, in parentheses, that means -3 plus, what's the next x? 1 plus the last x? 3, and then whatever you get, you're going to square it. Now, did we already do this sum part? Yeah, what did it come out to? So what's 1 squared? 1, okay? It's not always going to be 1, but Okay, you guys ready? So let's take all of the parts and let's plug them into where they go in the equation. So what was n? 3, okay. What was sigma xy?
23.
Sigma xy was 23, so that's going to be 3 times 23, because they're right next to each other, so that means times. Okay. Minus, what was sigma x? 1. Okay, so in parentheses put a 1. And what was sigma y? 3. All over. I'm actually going to put that 3 and 23 in parentheses. Okay, what was n? 3. What was sigma x squared? The one without parentheses. 19. So times 19. And that's going to be minus the sigma x with parentheses, which came out to 1. So minus 1. It's actually not that bad if you do each part individually and then you put it all together. So then you would put this in the calculator. The numerator, I'm going to do the math for you, but you would do 3 times 23, and then you would subtract 1 times 3, and that would give you 66, divided by 3 times 19, and then subtract 1, which gives you 56. Now, I do want you to put this in a decimal. So 66 divided by 56 would give you 1.18. Okay? And then we would basically do the exact same thing for B. So sigma y was 3. Hold on, guys. Sigma x squared was 19 minus sigma x was 1, right? Sigma xy was 23 all over n was 3. Sigma x squared is 19 minus the sigma x squared, which in our case came out to 1. Okay? So it's really all of the individual parts, and then you just have to put them together. The numerator, when you do all of that work, comes out to 34, and the denominator comes out to 56. So when you estimate that, B is approximately 0.61. So now to write our linear regression equation, we just plug in A and B into the formula. So y equals 1.18x plus 0.61. And we just did the whole thing that the calculator does like it.
All that work that I
Yep.